Hello, welcome to another short seminar by Comfort-Calc. Are you thinking about replacing your heating appliance? We're talking gas furnaces, oil furnaces, gas boilers, oil boilers, heat pumps, air conditioning. All these appliances need to be sized properly. In most cases, they're oversized. Oversizing appliances will cause them to short cycle, which can produce more maintenance issues and more service issues. We do manual J heat losses online. So let's sit back and listen to this video on why we need to properly size equipment. When you're sizing a piece of equipment, it can be sized by using what I call a sizing dartboard. In 43 years in this industry, I've seen some units oversized by 200%. The more common amount of oversizing done with heating appliances is 50 to 100%. This causes, again, more short cycling and higher maintenance bills. If you live in areas that get really cold, an oversized piece of equipment can actually make your house less comfortable when it gets colder because it's going to start and stop, start and stop. We want a unit that's going to be properly sized and run continuously when it gets cold enough that it needs to do that and give you a constant supply of temperature instead of the up and downs. Okay, when that unit is oversized and it starts and stops, starts and stops, starts and stops, starts and stops. It's kind of like driving your car with your foot all the way to the floor in the gas pedal or all the way to the floor in the brake. The more you do this, the less efficient your gas mileage is, the harder it is on your vehicle. The same thing happens to your heating appliance. The more it starts and stops, the harder it is on the equipment. It's better to bring it on, run it for 15, 20, 30, 40 minutes, an hour, and then turn it back off. We're putting in less fuel to get the same end result. When you properly size that piece of heating equipment, you're going to optimize the operation of that unit. You're going to have higher fuel savings. You're going to have more home comfort. You're going to have reduced service and maintenance costs. It runs like a well-oiled machine. When we put a new appliance in, and then we get a demand from that thermostat, if that appliance is oversized, we can put in a lot of fuel and go from one temperature to the next pretty quick. And that's not an efficient way to run your appliance. You want to run it a little slower, put in less energy to do that, even though it may take a little bit longer. And the longer run time will make it more efficient. What we want to do is make sure we get from point A to point B on the thermostat, but we want to do it at a slower rate and just increase the comfort level in the home and have less service issues. We can have a properly sized unit or we can have an oversized unit. When a unit's oversized, the same end result happens. You still get the temperature on the thermostat that you're looking for. But how we get there is more important. Do we want to get there using more fuel or do we want to get there using less fuel? In the more fuel application, we're going to get that demand from the thermostat and we're going to short cycle that product until we get to the temperature we want, as opposed to taking our time to get there and putting less fuel. Again, the same end result is we get to 70 degrees in this example, but at what cost? At what comfort level? Short cycling is less comfortable than getting there slower and having a constant heat coming out of your vents or coming out of your radiation until we get to that set point on the thermostat. Houses come in all shapes and sizes. There's different construction values. Insulation values are different. The types of insulation is different. The number and construction of windows changes. Is it single pane? Is it single pane with storm? Is it double pane? Is it triple pane? Lots of different construction values in homes across the United States. And we have to do a heat loss to match your home. So we just have to make sure that we get the proper information and get that heating appliance sized properly. Heat loss. What's heat loss? Heat is leaving the structure. That's what it is. And a lot of your heat really just goes through the roof. Now, do you slow it down with insulation? Yes. The higher the R value, the slower it goes. But we still have heat leaving the structure. We have sidewall heat leaving the structure. We have heat loss from windows, conduction right through the glass. We have seals around the windows. We have insulation stuck in the windows. They don't close tight. They just leak air. We have doors that leak air. We have to replace that weather stripping around the door occasionally, kind of keep a good seal there. We open and close those doors a lot. They wear. The chimney losses. Chimney losses are highest when the unit's running, of course. But when it shuts off and that chimney's warm, we could still be losing heat out the chimney. And we have exhaust vents, we have dryer vents. Then we have infiltration. Infiltration is when air enters the house. So if your unit's running and it shuts off and it's chimney vented, we still have this warm chimney venting air out of the home. Where does that air come from? It comes from outside. So therefore, when we bring that cool air in, we're cooling down the air inside the structure. So as long as that chimney's warm, we're going to be pulling air out of the house. When we run a fossil fuel unit like a gas furnace or oil boiler, we're going to use oxygen to burn, and therefore we're taking air out of the house. I mean, it's got to be replaced. If we run our stove in the kitchen, if we turn on a bathroom vent, if we turn on the dryer to dry clothes, a kitchen vent, that's all pulling air into the structure. And it comes in around the windows. If you have double hung windows where this little seam is between the top and the bottom window, it's going to suck air in if that seal's going bad. If you have seals around the doors that are going bad, it's going to pull that air in. The little doors on your dryer vents, if they don't close tight and they don't seal, you can suck air in there. Some people, those doors aren't even there anymore. It'll pull air through the dryer and into the basement area. So we have to get this air replaced back into a house. It's going to cool the air down that's inside the structure and cause your heating appliance to run more often. While there are proper ways of sizing heating equipment, there's improper ways also. And let's take a look at these. The building square foot method. So many BTUs per square foot of floor space. This is a crazy method that somebody has come up with. I've heard numbers anywhere from 70 BTUs per square foot down to about 20 BTUs per square foot. So we're not sure which is accurate. We don't know what numbers to use. It doesn't work. Just try to avoid using a square foot method. I've had a lot of people do it and their equipment is oversized. How about the tapping on the boiler or the ducts that are connected to the furnace? Let's go by that. I have a boiler with an inch and a half tapping. I need another with inch and a half tapping. That doesn't mean anything. Or the duct's a certain size. I need a furnace to fit that ductwork. Well, maybe that ductwork's oversized. Maybe it's not. Maybe it's undersized because it's old. A lot of the old warm air furnaces, the return ducts were too small. I can remember a rule of thumb way back when I first got in this industry 45 years ago, that they said that the return duct should be about a third less than the supply duct. Well, that's ridiculous because you can't get any more air out of a furnace than you get into a furnace. And today, the return ducts are usually larger than the supply ducts. Tapping sizes on boilers, they give you a tapping size for the largest boiler in that model range, but when you buy the smaller ones, they have the same size tapping, so you don't know which one to pick. How about the rating plate method? The rating plate on the furnace or the boiler or the heat pump, let's put the same size in. Let's match what's there. Well, did it heat the house before? Absolutely, it heated the house before. But was it oversized? Did the house get tightened up? If I even needed 100,000 BTUs in the past because my house is older, does that mean I still need it? Did I replace the windows? Did I update the doors? Did I add attic insulation? Did I do any sidewall insulation? Did I add it onto the house? All this comes into play. And we don't know if that old unit was oversized. And I'm going to tell you, with all the heat losses I've done, which is hundreds and hundreds of heat losses, I'm finding most of the heating equipment is 50 to 100% plus oversized. What about connected load on boilers? How much radiation's in the house? Who really cares? It has no bearing at all on the heat loss of the home or the sizing of the boiler. There's a really strong incorrect idea out there that says you need a certain amount of BTUs because you got to heat that much baseboard up. That couldn't be further from the truth. If you had a big building and let's say it had 1,000,000 BTUs of radiation, that they could put out 1,000,000 BTUs off their radiation inside that structure, but the heat loss was 200,000, you'd put a 200,000 piece of equipment in there. If you have excess radiation, that just means that you can operate with lower water temperatures and still get that water temperature up if we have to. But the idea is we don't want to oversize the appliances. We want them to run longer. When you have a smaller unit, it's going to run longer at a lower input. And one may think that that's going to use more fuel, but it's not. It's going to use that fuel more efficiently. So we want to make sure we properly size these units. So why is it important to properly size this heating equipment? It helps reduce short cycling. Again, short cycling can be argued a lot in what that means. Some say that, well, it depends on how long it runs. And other people say it depends on how long it's off. Well, it's kind of the same thing in a roundabout way. It's how many times it's running in an hour and how much it's off in an hour. If it runs 15 minutes in that hour and doesn't come back on for an hour, that's okay. I'm happy with that. But what about if it runs 15 minutes and shuts off for 5 or 10, and then runs another 15 minutes, and then it's off for 5 or 10? Well, that to me is still short cycling. If the unit's not running the entire time the thermostat is in demand, I think it's short cycling. Unless, things should just come on and stay on until the units are done heating, whether it's circulators or zone air systems, it should stay on. The appliance operates at a higher efficiency when it's properly sized. If we're going to have smaller units and they're going to run more continuous, we're going to have a higher efficiency. We're going to have less losses out the vent. Now we start getting into this modulating warm air furnace, modulating boilers, and they can modulate down to a lower input. That definitely helps save fuel because now that we're running long enough, we can drop that modulation down and put in maybe half the gas that we would, or put in less oil on some of the larger equipment, not so much residentially, but we can drop that input, drop the BTUs going in, use less fuel. We're going to have less breakdowns. The more that cycles on and off, the more failures we're going to have. Every time a part gets an inrush of power, it does suck some life out of it. And just think about short cycling. Just think about how that wears on things. If you got in your car and you turned your car on and you drove it to a stop sign, you turned it off, turned it back on, and drove it to another stop sign, turned it off, turned it back on, I could see that wearing out the mechanicals on the starter. So therefore, the same thing happens with any components. The more that they operate and shut down, it reduces the life of that product. So short cycling is going to do that, and if we avoid short cycling, we get higher efficiencies. If we put in a larger piece of equipment than we really need, it's louder. Now, today gas furnaces are quiet, heat pumps are pretty quiet. Oil products are different. They're going to be noisier, so we're going to have a quieter operation if we put in that smaller unit that's still going to heat the house. It's still properly sized. It's not like we're undersizing it, but it's going to be the proper size. Higher cost of larger units. If I'm going to buy a 60,000 BTU unit, it's going to be cheaper than buying a 100,000 BTU unit. So therefore, I'm getting less expensive installation. That's going to work better. It's not going to short cycle. It's going to have a higher efficiency. It's going to be quieter. And I'm not going to need as much maintenance and service on it because it's properly sized. Every job, be it a heating job or be it an air conditioning job, should have at least an envelope heat loss or what they call a heat gain. That's for air conditioning. They should be done. I like room by rooms because I think they're more accurate, but an envelope is when you're just measuring up the whole structure. If it already has duct systems and it already has baseboard, I can understand it doesn't really need a room by room, but it's amazing how when there's a room by room heat loss done, and a customer may call up with heating trouble heating a single room, you can look at that room and say, okay, that heat loss is this, and the amount of baseboard or the duct size going into that room is this, and we may not have enough because that heat loss on that room is higher than the rest of the house would be each room if you average them out. So it helps you to pinpoint trouble spots, and that should always be asked when the survey's done for sizing equipment is how's the house heating? So in sizing a heating appliance, what doesn't even matter when it comes down to sizing the new appliance? The pipe size or the duct size doesn't really matter because that has to do with operation, not with sizing. Water volume, the same, not with sizing. Type of radiation, could be a lot of water volume or very little water volume. It doesn't matter when it comes to sizing. Sizing is all about heat loss. The amount of radiation that you have in the house doesn't matter. What about the rating plate on the old boiler furnace? Doesn't matter. The square footage of the home doesn't matter. Now I say that kind of reluctantly because what I mean by that is we don't want to apply a rule of thumb to the square footage of the home. The square footage of the home is calculated through the heat loss calculation, but we're not going to apply a number of BTUs per square feet. It just doesn't work. I've had larger homes have less heat loss than smaller homes because the smaller home might have been older, more drafty, then the larger home could have been newer, better insulated. So we don't really have a square foot number that matters. And so anything that's in that column there doesn't matter. It can affect the operation, but it's not going to affect the size of the product. So what does matter? The heat loss. That's it. If we do a heat loss, it's an accurate heat loss because you supply the proper information, which is real easy with the forms. It's going to work every time. I had one job in 40 years that the guy said it didn't heat the house. Just one. And when we got to talking, it was a newer home going in, newer home. He was he was going from warm air to a boiler. So they were putting in a baseboard. He bought the house, it had a warm air system. The house was only 4 or 5 years old. And he called me up and he says, well, the boiler's in and we got our first cold nights and it's not heating the house. Well, that's kind of a panic moment because it's the first time it ever happened. And I've done heat losses in Alaska and Canada and all across the United States. Never had one go bad. And I asked him about the piping on the radiation. And the contractor left the boiler, went upstairs, went all around the first floor, went up to the second floor, went all around the second floor, and back down to the boiler with 3/4 inch pipe. 3/4 inch pipe doesn't carry enough BTUs to heat that whole house. So what he had to do was split it into either 2 loops or 2 zones, and that's what stuff we'll talk about more in depth in our technical seminars that are on our website. So the only thing that really matters is heat loss. Now I'm going to throw this in here because it's the amount of radiation in the building. Now I put that in there not for hot water boilers, but for steam boilers. When you have a steam system, we do not do heat loss calculations on steam systems. We size off the radiation. And the only reason for that is that these steam radiators were installed way back whenever the house was built probably. And the house could have been a lot more drafts back then, no insulation. It could have been tightened up since then, but we still don't do heat losses. If a steam boiler is going to go into a house, we have to measure the radiation because the boiler must produce enough steam to fill the piping and fill the radiators. So therefore, it's sized differently. We can do sizing on a steam boiler, and it's very inexpensive to get it done because it's pretty easy. A lot of times homeowners can do that themselves. In fact, we even talk about that on our website. There is a page that talks about sizing a steam system, and a homeowner can do it themselves because it's just that easy. So what else matters when it comes to sizing the appliances? I don't know. I don't know of anything else. I still don't know of anything else. So all that matters is heat loss. All that stuff on the left, duct sizing and pipe sizing and water volume and all that stuff doesn't matter. Heat loss is the only thing that matters. If you have a boiler, gas or oil fired, furnace, gas or oil fired, heat pump, air to air, air to water, none of that matters. Even if you have a ground source, it's going to be the heat loss of the structure that makes the difference. How's getting a heat loss done online work? Just download our forms package. It's a lot of information on there. We give you options to download a PDF file that you can type information. It has drop down boxes, or an Excel file that has drop down boxes. You can type things in, or just write on the forms. You can just print out the forms if you want. But just download our package and then decide what you want, premium or standard, and decide if you want to do it through a PDF or an Excel file, or just write it out. If you write it out, please be legible. Fill out the first page, which supplies us with your contact information. We have to know who we're dealing with, what a phone number is, what your mailing address is, what your zip code is, so we can determine the proper outside design temperature for you. Page 2 supplies us with important information about your home and current system. Do you have bathroom fans? Do you have kitchen fans? Are there fireplaces? What do you keep your thermostat temperature at? So a lot of good information there. Then you measure and record all the information on our room by room heat loss forms. It can be in feet and inches or all in inches. Please use feet and inches or all inches. No metric, please. When completed, you either mail or email the completed form to us, however you want to get back to us. We'll do the heat loss calculation using our Manual J software, usually over like 5 working days. Give us 4 or 5 working days. A lot of times it's 2 or 3, but give us up to 5 days. And then we'll assist you throughout the entire process. One thing I can add, which really made a big difference on doing heat losses over the last few years, is people have been starting to send in more pictures of the outside of the home. That really helped me. So we ask you to draw a floor plan. It doesn't have to be close to being accurate. I don't care if a 10 by 12 room looks smaller on a drawing than a 4 by 5 room. It doesn't matter to me. I just kind of want to see where the layout is, and then just do north, south, east, west on there. You'll see in the samples. Just doesn't have to be on graph paper or anything like that. Just a rough sketch, so I know what's north. What wall is north, and then I can figure it all out from there. So we'll do that. But just quick pictures around the house. I've had a couple people just start at one corner of the house and just walk around the house with their phone and do a quick video. And that solves a lot of problems when I start having questions in my mind about things. And sometimes I'll pick up where somebody put the wrong direction on a room. And I said, wait a minute, though, that room is here and that's not an east wall. So pictures are great. A little video on the outside. Please, no pictures inside your home. I don't want that. So just outside the house is great. Or draw, again, a floor plan is good because it tells me where the rooms are, what rooms are beside them. Again, picture's worth 1,000 words, but just a drawing inside, please. We have 2 different types of heat loss plans. We have the premium plan. The premium plan means we're going to do your heat loss after receiving your information. We'll run it the second time. Like I said, sometimes that clears things up. We can rerun the calculation if you want to compare the original heat loss to what it would be if you were going to add insulation or maybe windows or doors. You're going to make changes to the house. We're going to do that maximum of 3 times. If we do it more than 3 times, there will be an added fee. If you have questions on your contract, we're going to help you with that. Under the premium plan, we will actually help you not decide on who to take and not decide on what equipment. We're not going to discuss pricing. We're not going to discuss manufacturers. But if you have specific questions about the application, we can help you with that for up to 6 months after we ran your original heat loss calculation. The next one's a standard plan. The standard plan, we're going to run the calculation from your forms after we receive them. We'll answer any questions or concerns about the calculation for up to 30 days. And that's it. So there's a price difference between these two. So one is we're going to give you options. We're going to discuss contract with you. We're going to rerun it if you want to. So we have a lot more work we can offer you. But in the standard plan, we're going to run the calculation after 30 days. Thank you. So now what? So now we're going to help you maximize your efficiency if you have a boiler. A modulating furnace works a little bit different, but a boiler, we have water temperatures we can deal with, and we're going to help you with that. And we're going to maximize the efficiency on that boiler. It lets us limit the maximum amount of BTUs that the boiler can input. Let's set a proper minimum water temperature. It's dependent on type of radiation you have. Is it large water volume? Is it low water volume? How do we do this? We're going to do a second heat loss. Now, this is not part of the 3 extra ones that we would do. If you ask for this help, we will actually do the second one and just include it, because all we have to do is change the outdoor air temperature. That's it. So if we do 0 degrees, let's say outside air temp, and then we'll do one at 50 or 55 degrees, so we can see the minimum and maximum amount of heat you need. And it's a big difference you'll see in upcoming slide. But this second loss is only to help decide the air temperature or the water temperature we need. We're going to have to measure the amount of radiation per zone. That's something you're going to get back to us on. We have a separate form for that. How much radiation do you have in each room? And then tell us, is it zone 1, 2, or 3? Like a bedroom zone, or the thermostat is in the living room zone, even though you may have other rooms on that same thermostat. That's what we would have to know. And then we do the math and we explain it to you. So we can help add more efficiency to your operation. So once we get the heat loss done, you're going to get a long form and a short form. The short form is just kind of an overview of your heat loss, as you can see what's on the screen now. And then we're going to have a detailed information that we're also going to send out. So you're going to get 2 forms back from us. One's a quick one, just give it to your contractor and he can look at this and see what the heat loss is and the heat gain for air conditioning if you're going to get both. We always include the air conditioning side of it. So that's information that he can use. And you can see in this situation the heat loss to the total heat loss BTU right on the right side says 91,008. So this 2,493 square foot home has a heat loss of 91,000. But I said we also can do these at 50 degrees or 55 degrees also. Let's see what changes. So we change that to 50 degrees because a modulating piece of equipment, we don't always need that maximum input. And now if we take a look at what this heat loss is, we're down to 28,677. So we went from 91 degrees at 10 degrees outside, and now we're running it at 50, and we're going to be at 28,677. That is a 70% heat loss reduction on your home. So this is why we don't need on and off boilers running 100% every time they're on. We can modulate that burner up and down and meet this heat loss as the outside air changes. And that's the big fuel savings in modulating heating equipment. You have modulating heat pumps, you have modulating boilers, you have modulating furnaces. So all this stuff modulates. It's going to be a little bit more expensive, but there's also the on and off equipment. And sometimes people just want to stay with that because it's more simple. So thanks for viewing our heat loss calculation seminar. And if you want technical information, we have a complete list of more in-depth technical seminars on our website. Just go to comfort-calc.com, click on seminars, and there's a lot of other information on there. The website is dedicated to steam and hot water boilers, but the heat loss works on any heating appliance. So if you like what you saw, please subscribe and you'll be notified anytime a new seminar comes out. I've got 5 of them I'm working on right now. And then just smash that like button to help the algorithm on YouTube. Again, thanks for watching.